So Shrikant, yeah,
Hey, hi guys, good morning.
morning. Shrikant, I have a query here.
Yeah, go ahead.
Yeah, regarding the cluster sampling, you had given advantages and disadvantages. So the last points in the advantage and
Mm,
disadvantage I could not understand. Unavailability of sampling frame prohibits using other random sampling methods. I mean, what is the advantage? I didn't understand. I mean,
okay, one second, let me pull it up. Okay, so let me share my screen. This is the one you're talking?
yeah. The
Okay,
last points in both advantage and disadvantage. Unavailability of sampling and yeah, cause and problems. Also, yeah, maybe you can elaborate a little bit more.
okay. So, unavailability of the sampling frame prohibits using other random sampling methods.
Yeah, I didn't understand. I mean, what is it saying here?
Mm, yeah, so basically what it's saying is the advantage is that, as I mentioned, as I mentioned that when you use a random sampling, Uh, so generally in the simple random sampling, you don't consider any of the characteristics of the observations and you randomly pick up the observations from the entire data set, right? And then if we have some kind of indication about what characteristics or what strata, okay, we need to consider, then we can create the strata is known as nothing but the sampling frame. So if we understand from what kind of sampling frames are available in the data, then we can go with a stratified sampling. In case there is no availability of that sampling frame, then in that case, this clustering sampling would play a important role. So as I mentioned that if there are multiple characteristics and if you don't have a clue like, which all are important on what basis, you should able to come up with the stratas. In that case, you can go with this clustering sampling technique where you can use an algorithm and the algorithm will create you the unique clusters, identify the unique clusters from the group, and from each of those groups, you can randomly select the observations. Got it? So sampling frame, just for your understanding, just consider it as a stratum or strata.
Okay,
Is that clear?
strata. Okay, strata is a part of.
Strata
Uh,
in the
that is a
population, these are the unique,
yeah,
yeah,
subsets.
non-overlapping,
Yeah,
non-overlapping groups.
that is in stratified random sample. The example that you're saying. So
Yeah,
this is
so
cluster, no? Uh,
I'm saying if it is not available in the
okay,
unavailability of sampling frame, in the unavailability of the stratas, there you can use this cluster sampling. That is the advantage.
okay,
Got it? Because if
okay,
you don't have that sampling frame or strata, then it prohibits using other random sampling methods like stratified random sampling.
okay.
In that case, we can go with the cluster sampling. That is the advantage. Clear?
Right, fine, fine.
Okay.
Got it.
Okay, now you're talking about this thing, right? So what is the disadvantage? The cost and the problems of statistical analysis are greater than. So now here, as I mentioned, this cluster sampling comprises of the machine learning algorithms or statistical algorithms we use, to come up with the cluster. So having an understanding of those statistical analysis is required, and again, there could be a cost, right, associated it. You need to have a platform, you need to have a tool and technology to run that particular algorithm. So in that case, it is just considered that the cost and the problems of statistical analysis would be greater, okay, when compared to any other random sampling. So in the random sampling, simple random sampling, you need not to run any algorithm. It is just randomly you have to pick the observations or the objects. So in that case, relatively, when compared to the simple random sampling, the cluster sampling will be associated with some kind of cost and problems, okay, of statistical analysis, because it is a statistical way of identifying the clusters from the data.
Okay,
It's
fine,
not
fine.
just simply you go and pick up the observations.
Okay, fine.
Got it? All right. Any other questions, guys? Okay, so let me shift to. Can you see my slide of confidence intervals?
Yes.
All right. Just a quick recap. Yesterday we talked about this point estimate and confidence interval. Does anyone remember what does that mean? What do you mean by point estimate? I'll just come to the main slide. Uh, yeah, so if somebody asks you, what do you mean by point estimates or confidence interval? What would be your answer? Though we have touched at a very high level, but anybody remembers or can anybody explain me whatever you understood in the last class? Just try explaining me in a very layman terms. That's fine. How do you mean by point estimate?
Point estimate will be like, we take a sample and from there we try to
Mhm.
estimate the whatever the analysis is. And then there might be some error in that. So we can test it with some sort of a hypothesis testing and all. I think that was related to your inferential statistics.
Yep. Okay.
So
Okay.
there might be some error, margin of error in that
Right.
estimation.
Right.
So that is what we call interval of confidence, I believe.
Good. Good. So yeah. So point estimate is what is when you have to infer about your population on the basis of sample. Then whatever sample statistics we calculate, that is known as point estimate. It could be the mean, it could be the variance, or it could be the proportion. These are the three major estimates what we uh, calculate on the sample to infer about the population. Now, when we are taking the sample, definitely we may not arrive to 100% accuracy. Okay, we cannot say that this particular estimate which we have derived from the sample is 100% um, coinciding with my population parameter. Okay, so at exactly 100% same as population parameter. So definitely there could be some margin of error. So to avoid that uh, incorrectness and to avoid that margin of error, what we do is we consider the interval. So rather than estimating just a point, what we do is we consider the range or the interval, which we call as a confidence interval when we have to infer about the population. So now today we will discuss like how can we calculate the confidence interval. Yesterday we have kind of discussed like in our real life also when we have to commit on something rather than giving any point estimate, we rather prefer giving them the range. Okay, if somebody asks you in how much time would you come, so you will not say that 20 minutes, 60 seconds or 50 seconds or 55 seconds, right? It is you cannot be that much precise in terms of estimating that. Okay, so you will roughly say that okay, I'll be there in 15 to 20 minutes there. Okay, depend on your confidence, right? So here statistically also we follow the same approach, but here we follow some scientific approach to come up with that confidence interval. It's not just blindly or uh, just like that, okay, we come up with that range. So there is a scientific approach, a method which we follow to come up with that confidence interval. Okay, so And this width of your confidence interval, now tell me, does it uh, reduces with the increase of confidence interval, or the width of confidence interval increases with the increase of confidence level? How the width and the confidence are related to each other?
Inversely proportional.
So if so you are saying if the confidence is high,
Yeah, it should be less.
the width should be less.
Yeah.
Okay. Anybody else has a different opinion? Okay, so now let's suppose this scenario only we take. You tell me, would you be more confident by saying that, okay, I will reach in 15 to 20 minutes, or you will be more confident if you say that I will reach between 10 to 40 minutes? In which case you will be more confident.
10 to 40.
So that means your confidence is directly proportional to your width, right? If your confidence is increasing, your width is also increasing, right?
Yeah.
Okay. So if you are 100% confident, then that means you will give a very wide range. Okay. You will give a very wide interval. In that, you will be 100% sure that I would reach in that particular interval. But that that width, because that interval is pretty wide, okay, if you give that kind of an interval, would that make any sense? If you are saying to somebody that I may reach in between 1 hour to 7 hours, doesn't it make sense to anybody? Okay, so he cannot take any decision, he cannot plan anything, because that much is the variance, right? So that's the reason we don't go with an 100%. If again, in the data, if there is too much of variance, it would directly impact your interval, okay, width. In that case, even with a lower confidence, your width could be very high, could be very large. So we'll see that, okay, how that we can see in the data with the help of certain scientific or statistical methods. Okay, so that's understanding about this particular slide. So rather than going with a point estimate, we better go with a confidence interval. And this confidence interval is directly proportional with the confidence. If the confidence level increases, then your width of the confidence interval also increases. Mm, okay, yes. Now, what is this confidence level? So just imagine in this way. Okay, if you are saying I'm 95% confident that I would take around 10 minutes to 20 minutes, then what is that 5%? So you're saying 95%. What is that 5%? So 5% is you can consider it as a scope of error, right? So that means there could be a chance, 5% chance, that you cannot be there in this particular range. Okay, you can be either earlier or can take more than 20 minutes, right? So we call this that 5% in statistics is denoted as alpha. We can call it as a risk level, or we can call it as a significance level. Significance level. So if somebody is 95% confident, then that means there is a 5% of risk of error. Okay, or we can call it as that 5% is nothing but the significance level. So confidence level is nothing but 1 minus of that alpha. Usually, every time in statistics, we talk about alpha, we don't talk about confidence level. So when somebody is giving you alpha, they will say that my risk appetite is 55%. Then automatically your confidence in level would be 1 minus alpha, that is 95%. So generally in this industry, when anybody is using statistics, they will only talk about alpha, they don't talk about confidence level. With the help of alpha, we have to derive the confidence level. So, for example, in the life sciences, they will say that whatever estimates you are giving, you know, um, uh, I cannot take the risk beyond 3%, because in life sciences it is it is very risky, to go with any estimate blindly. Okay, so there the risk appetite is very low. So they will say 3% or 2% is my risk appetite. So that means they will define the alpha, and based on the alpha, we will define the confidence level. While in the marketing and the sales, there the risk appetite could be high. Okay, they may say that okay, I can take it till 10%, okay, 10% or 15%. So their 85% confidence level or 80% confidence level will also be okay. Okay. So alpha is known as significance level, and the confidence level is equal to 1 minus alpha. Okay, so now comes the estimation, okay, of the confidence interval. So for estimating the confidence interval, you require these three different measures. Okay, one is the point estimate, and we know how to calculate the point estimate. We take the sample, and from the sample, we have seen, right, how we can calculate the mean, variance, standard deviation. Okay, and the proportion is nothing but you take the count of object which is of your interest divided by the total number of observation. That will give you the proportion. For example, in this sample, I want to know like how many objects are defected. Okay, so I randomly picked certain objects. I want to find out how many objects are defected. So I'll take the count of all the defected objects, and then I will calculate the proportion. That is my p hat. Okay, and the variance and the standard deviation, you know how to calculate. Okay, and then also know how to calculate the mean. So these are the major point estimate which we calculate from the sample. We also call as sample statistics. So this we know how to calculate. Then what we do is this X bar, whatever point estimate we have consider, we will add and subtract some term to it, based on which we will get that interval. Okay, so this is my point estimate. I will subtract something to this particular value, then I will get the lower limit of the confidence level, confidence interval. And then if I add a certain value to this point estimate, then I will get the upper bound, okay, upper limit of that confidence interval. So in that way, I will get this complete confidence interval. Now, what is that term? Now, this term is known as margin of error. In short, we call it as MOE. Okay. So this margin of error, the formula of this margin of error is reliability factor into standard error. So now these are very statistical terms, okay, and we need to understand clearly how these terms or how these measures would help us, to estimate the margin of error. That's something we will see. Okay, and this reliability factor, this depends on the confidence level. If your confidence level increases, this reliability factor will also increase. If this reliability factor increases, automatically your width of the interval would increase, because this value, as this value would increase, so the plus minus of this particular point estimate would be larger than before. Okay, so and now the standard error, this is primarily, this captures the variance in the data. Now, this will also impact your interval size, interval width. If there is too much of variance, high variance in the data, then that also would impact the width of the interval. Now, let's get into detail and understand, what is that formula. Okay, so by now, just ignore this part. Okay, just understand how we can find out the confidence interval for mu. So for mu means I have a population. The population mean is denoted as mu, and I do not have any clue about this mu. So I need to infer about this mu from a sample. So what I will do, I'll take a small sample from this population and I'll calculate the sample mean. Okay. Now, definitely there could be some sampling error in that case. So I will go with my interval. So confidence interval, I can put it as X bar plus minus margin of error. Now this margin of error is nothing but my reliability factor into standard error. Now this reliability factor, we denote it as Z alpha by 2. Now alpha, if you see, this is your significance level, right? So with this significance level, we will able to calculate the confidence level. Guys, are you following or am I going too fast? Okay, so stop me if I'm going too fast and if you have any confusion anywhere. Okay, so this reliability factor is given by the term Z alpha by 2. Now, what is this Z alpha by 2? Now, Z in statistics is called as standard normal distribution. So we call it as Z distribution. So in statistics, majorly it's all about distributions, guys. Okay, it's all about probability. It's all about distributions. So what they have done is statisticians in the past, they have discovered various distributions. So now how that would help is if we know that our data is following particular distribution, then we can able to calculate the probability of a particular value to occur. Okay, so if I'm saying, let's suppose my data is like this. Okay, and this is my X values. So let's suppose a certain value is like minus 1.5. Okay, so if I know that my data is following a Z distribution or following a standard normal distribution, there would be a table, there would be a method through which I can able to, and this is known as probability distribution, and this is a probability on the y-axis. I can able to find out what is the probability of occurrence of this particular value as 1.5. Okay, that's the beauty of these distributions. So here in statistics, we generally make assumption, okay, or we compare our data with this with these distributions, okay, and then we refer the probabilities from this distribution and then apply it on our data. So I think it's somehow you guys are getting confused. Okay, so let me put it in this way. Now you have a data, okay, you have a sample data. We don't know a distribution, how is that, and you need not to check also. Okay, you just consider or assume that that is following a Z distribution. So yesterday we talked about central limit theorem. Generally, it's always better, you go with a larger sample. So if you go with a larger sample, central limit theorem states that, okay, it will follow a normal distribution. So if you have considered a good size of sample, then you can assume that it is following a Z distribution. Now we will use that Z distribution as a reference, okay, and then we consider the properties of Z distribution and apply that onto this data. Okay, so what are the assumptions here? The population, the first assumption is we assume that the population variance is known. Okay, so that means I know something about the population. I have some idea that, okay, in the population, the deviation could be somewhere this value. For example, let's take the manufacturing scenario. As a quality manager, I've been seeing or I've been measuring the quality since last 10 years, let's suppose. So I have an idea. So I'll say that, okay, in this population, okay, whatever products we are manufacturing, roughly the variation in the quality is, uh, let's suppose 5% or any other units, okay, 5 mm or 50 mm. Okay, so I will have an idea. So if that is known, then you have to follow a certain technique. If you do not have any clue about the population, what is the variance, nothing, okay, then we have a different approach, which we will discuss in the subsequent slides. Here we are taking the assumption that, okay, variance is known, and we are taking another assumption that it is normally distributed, and we are taking also another assumption also, if the population is not normal, but we went with a large sample. Okay, that comes through central limit theorem. If we are using a large sample, then automatically we can assume that it will follow a normal distribution. Okay, so generally, this is the assumption. You need not to check about this. Okay, you just, if you are taking a good large sample, then you can go ahead and then you can use this particular formula. Now the formula is this. Okay, so this is my margin of error. This margin of error I am subtracting from my point estimate, and I'm also adding to my point estimate, and that is giving me the interval. And I am saying that, okay, this mu lies somewhere in between that particular interval. It could be greater than this, the lower limit, or it could be lesser than the lower limit. So if you remember this, so here I'm saying, this guy is saying I'm 95% confident that mu is between 40 and 60. So 40 is the lower limit and the 60 is the upper limit. So here in this formula, so that's what it is denoted as, with this notation. So this is my population parameter. I am saying that this population parameter lies in this particular interval. So this is how I have denoted. Okay, so now let's understand this. This is the most important part of this particular formula. And this is the standard error formula, alpha sigma by root n. Okay, so where n is nothing but the sample size and the sigma is the standard deviation of the population. So as we assuming that, okay, we know the variance of the population, then we can derive the standard deviation based on that, and then we can able to calculate the standard error, because this is known to us and the sample size is also known to us. Now this is known as standard error. Okay, so do not get confused with standard error and the margin of error. Standard error is nothing but a error which may lead because of high variance or high standard deviation in the data. So that is denoted by sigma by root n. The margin of error is the product of reliability factor as well as the standard error, and the reliability factor is proportional to your confidence level. Okay, and the confidence level is derived from the significance level. So I think you can connect the relation now. Okay, so usually in the any business problem or any
I'm sorry to interrupt. Can you
yeah,
please
go ahead,
repeat
go ahead.
again the sigma by root n thing? I missed it somewhere.
Okay, so I mentioned about the standard error, right? The standard
Okay.
error is nothing but your sigma by root n.
Root n. Okay.
So this sigma is your population standard deviation.
Okay.
Okay. Now see, in this whole process, what we are doing, we are trying to get some idea about the population, right? So that I can infer about the population, and based on that I will make a decision. So if you are running a big plant or okay, manufacturing plant, and you want to infer about the quality, so definitely you cannot go and check the quality of every product, right? It is highly impossible. So what you can do is you take the sample of few products, okay, and then make sure that you are collecting it. The sample comprises of different products coming out from different machines at different times. So whatever, based on your business understanding, you have to consider all the factors while considering the sample. Once you have that sample, you can estimate the point, you can estimate the sample statistics, which we call as point estimate. Now, definitely there could be some scope of error. Okay, it's not like, that complete sample will give you an accurate indication about the population parameters. So better you can go with the confidence interval. So now, let's suppose as a quality manager, your risk appetite is around 5%. So you are okay to go wrong by 5%. 95% you want to be accurate, because you cannot go 100%, because 100% it will give you the pretty wide interval, and that would not make sense. Okay, so if you are going with a 95% interval or the confidence level, then you have to go and calculate the reliability factor. Okay, and based on that reliability factor, you can come up with the interval. So standard error is something very simple. Okay, if you have an idea about the population variance that in my plant, the quality of the product generally varies by this much percentage or this much units, then you can consider that as a sigma and then divide it by sample size. Then it will consider as a standard error. Okay, so instead of standard deviation, we go with a standard error, and the standard error formula is sigma by root n. And whenever you are using standard error, that comprises that you are talking about sample, because the denominator is your sample size. Okay, so this part is clear, standard error.
Yeah.
Okay, now let's discuss with the reliability factor. Here, you guys, please pay attention. Okay, this is very important, and this part, we have to we will discuss in every major concepts in statistical analysis. Okay, because this is very, very important. And as I mentioned, in statistics is all about distributions, probability distributions. We have so many distribution. We have Z distribution, T distribution, chi-square distribution, F distribution. So exponential distribution, Poisson distribution. So statistics, a good statistician is somebody, who understand all this distribution, and who knows where to refer this distribution. Okay, so now for this particular confidence interval estimation of the mean, it is recommended to follow or to refer to the Z distribution. And Z distribution is nothing but it is called as standard normal distribution. Now your question would be, what is this standard normal? We discussed about normal distribution, but what is the standard normal distribution? So standard normal distribution, again, it's a normal distribution only, which is symmetric, but here it has one specific property. Standard normal distribution has a mean equal to 0 and standard deviation equal to 1. Okay, now this is a distribution which statisticians, they have discovered, saying that, okay, here the mean is equal to 0 for this distribution and the standard deviation is equal to 1. So if I draw it in this way, so what does that mean is, here the mean, which is in the center, will be 0 in the standard normal distribution. And the values will be equally distributed on the either side. So if you look at the values on the left hand side, these would be negative. And if you look at the values on the right hand side, these would be positive. And the deviation in the of these values, okay, on an average from the mean is equal to 1. So it is that symmetrically distributed, and it has a very unique property of this, having mu equal to 0 and standard deviation is equal to 1. So with this, they have come up with one, a table known as Z table. Okay, by looking at that Z table, you can estimate that, okay, if your value is 1.5, you can go to the table and then you can find out what is the probability of getting this number as minus 1.5 from this distribution. Assume in a way that, okay, all the values are in a particular box. Okay, it's a black box. All the values are there inside that. So if I know the distribution of that data, if I randomly pick any particular value, then if you want to know what is the probability of that particular value to be get picked, okay, that you can derive out of this Z table. Okay, now this is just as a reference to understand the probability. Okay, so that probability we will use it here and then multiply with the standard error. So that will give me some kind of so for example, 0.5 into this error. So there is a 50% chance of making the error, okay, in this particular scenario, in this particular sample, and that this 50% you can quantify, okay, based on this distribution. For example, 50% probability is equal to plus minus 1.6. Now, this is the reliability factor. Now, this is just, you can consider it as a constant or a scalar term, which gets multiplied with the standard error, and that basically magnifies the standard error by that rate. So based on the confidence level. Okay, so once we do it, I think you will able to understand. Okay, so now this is all discussed. Okay, this is the confidence interval formula. It can be also written as x plus minus margin of error. ME is called as margin of error, where the margin of error is nothing but reliability factor into this standard error. Now, this is clear. This is something, okay, we need to understand what it is. Okay. Okay, now before getting into this, now let's again this from the interview perspective, this would be very important, and there's a reason I put one slide on this. Now people will say that how you can reduce the margin of error. This is the general question, okay? Even while working on any of the use case, people may say that, okay, how would you reduce the margin of error? Because if your margin of error increases, your width increases. If your width increases, it doesn't make any sense for the business to make decision based on that width. If you're giving a very larger width, if I say that, okay, your sales, business sales for the next month would be somewhere between $100 to $1,000. So how the business will make a decision like how much to stock, how much to plan, right? Because it is a too large interval, okay? So then you can say that, okay, this is what I'm getting because the margin of error is high in your data. Now, business may ask you, okay, go and reduce the margin of error then. How you will reduce the margin of error? So now it is all about this formula, okay? So first thing is, you have to understand this margin of error is proportional to what all values. So first thing is, this margin of error is proportional to this sigma. The population standard deviation can be reduced if it is reduced, and that is not in our hands, right? So for that, the business has to take right measures in putting the right process in deploying right machines, right resources, right people to overall in the population to reduce the variance. The quality parameters should not vary too much. So now the business will get an idea, okay, it's happening because of the standard deviation of the quality parameters, because of which the margin of error is increasing. So this is one controlling factor which business can take. Second, which is in our hands, is the sample size. If the sample size is increased, so margin of error is inversely proportional to the sample size. If you increase the sample size, your margin of error would reduce. So that is nothing but your sampling error. If you're taking a small sample size, definitely there could be a higher margin of error. If you are taking a larger sample size, then your margin of error or your basically the interval would reduce. Okay, so go with a sample size. If your width is coming too large, then you can go ahead and increase the sample size and see that, okay, if you can come up with a smaller interval. The second is the confidence level is decreased. If the confidence level is decreased, your margin of error would decrease. If your margin of error would decrease, your confidence interval would decrease. Okay. So these are the alpha and your sigma and your n. So these are the three important measures through which you can control your margin of error. Okay. And if you don't suddenly remember all these terms, just try to remember this particular formula, and with this formula you can able to describe, by what all factors, okay, you can reduce your margin of error. Okay, now come to this point. This is the most important point. Okay, Now, there are three things which we need to understand here. First thing, I think you might have noticed that here we are using alpha by 2. And what is this alpha by 2? So we know that confidence level is equal to 1 minus alpha, where alpha you can consider it as a risk. Okay. So whatever risk appetite you have, that you can consider it as a alpha. So if I have a 5% of risk appetite, then my confidence level would be 95%. Okay. So now, instead of using just alpha, we are using alpha by 2. Why? Okay. Now the point estimate is nothing but this x bar, and the confidence interval is nothing but x bar plus minus margin of error. Now, if you see this plus minus, what we are doing is we are not biasing our thoughts saying that this margin of error would be on the right side of the mean or on the left hand side of the mean. Okay. We are very fair. You are saying this margin of error could be on the either side. So what does that mean is this mu, which is your population parameter, I am saying it could be less than this x bar, or it could be higher than x bar. Okay. So in that case, I'm giving a chance of error on both the sides. There is an equal chance of committing an error. So your mu could be greater than x bar or could be lesser than x bar. So there's the reason I'm saying this plus minus margin of error. And this margin of error, I'm adding and subtracting from the point estimate to distribute my error on both the sides. Okay. So when I'm saying distributing my error on both the sides, I'm equally distributing that error on both the sides. So here where my risk or where the scope of error is nothing but alpha, I'm considering the half of that error, half of that risk on either side. So when I'm calculating the reliability factor, okay, to calculate the margin of error, I will calculate on alpha by 2. Okay, because that's how I am dividing my entire error in two parts. So why we are doing this? So if I take x bar and if I calculate the margin of error on alpha, okay, if I take margin of error on alpha only, so what will happen? That margin of error will be subtracted from x bar and would be added on x bar. So if you have a confidence interval, so this side also it would be alpha and this side would be also alpha. Then together it would be 2 alpha. So where my appetite was just of 5%, if I am taking alpha on either side, the total risk would be 2 alpha, which is 10%. Okay. So in that case, I may go wrong. Okay. The business would not accept. So what I will do is this risk I will divide into half. Okay. Now here I will take half, here I will take half. And together it would be total, it would be alpha in the entire confidence interval. So that's the reason we go with the alpha by 2. Okay. So I think this part is also clear. Now comes the Z distribution. Now here we are talking about the percentage, the risk of error. So risk of error means you can consider it as a probability. So what is the chance of getting a risk is nothing but the chance of or the likelihood of anything to occur is nothing but the probability, right? So from the distribution of Z distribution, we'll try to find out, we'll quantify if there is a risk of 5%, then what would be the value at 5% probability? And that would be my Z value. Okay, so for example, this is my Z distribution. As I mentioned, the Z distribution has a unique property of having mu equal to 0 and the standard deviation is equal to 1. Now what, and it is a very, I'll say, beautiful distribution. Okay, it is a very nicely, what do you say, distributed, and it is very much symmetric. Okay, so so in this distribution, when we capture the probability, So the probability would be nothing but it would be the region, okay, or the area under the curve. So for example, if I say what is the probability of getting a value minus 1.96. Now, if you take this y-axis, now if you take this particular value, this will give me the probability of getting this particular exact value of 1.96. If I'm want to know what is the probability of getting a value minus 1.96 or less than minus 1.96, then this area under this curve will give me that entire probability. Because this is known as probability distribution curve. If you remember, I've shown you a density curve in the Python class. So once we draw the histogram, after that, I have shown you one distribution. So that is known as density curve. So that density curve will give you the probability. Okay. So here also, this is that curve. It will, through this curve, you can able to understand that what is the probability of getting a value as 1.96 or any other value or less than that value. So that will give me this region of the curve. So if you know this particular area of the curve, then you can able to decide, what is the probability of getting these number. So the entire area under this curve is equal to 1. Okay, because the maximum probability is equal to 1. So that is how, this probability distribution needs to be referred. Okay, so for now, just understand this is one distribution. And once we discuss about probability and the probability distribution in detail in the coming classes, there will get even much more clarity. But just for now, just understand that, okay, now this is the distribution. And from this distribution, we need to find out the Z value based on the alpha value. This is what is the task. Okay. So now we know this alpha because it is been stated in my problem statement. The business has given me their risk appetite and they have given me the significance value. So alpha is known to me. And with this alpha, I will go and calculate the Z value, okay, from this particular distribution, from this Z distribution. So I cannot go and directly consider this alpha because here I have to calculate the confidence interval. So I will divide this alpha by 2 and then that error on either side I will go and calculate. So I will take alpha by 2 now. Okay, and that alpha by 2 I will find out here in this distribution. Now, as I mentioned, this alpha by 2 could be on the left-hand side and could be on the right-hand side. So this is my mu, right? So now I will just put one second, better I will take one blank slide. Guys, if you get this concept now, so it would be very easy for you to understand rest of the things because this is something, okay, which is complicated. But if you get that, then it will make it very easy for you. Now, let's suppose this is my Z distribution, which I will refer to solve this particular problem. And this Z distribution has a unique property of mean equal to 0. Now I have a sample here. This sample, I will kind of relate to this particular distribution. Now for this sample, I have this X bar. Now this is my sample distribution. Now I'm saying to calculate this confidence interval, I'm saying this risk would be equally distributed on both the sides. So here it would be alpha by 2, here it would be alpha by 2. Here I cannot go and find out the probabilities because it's hard, you cannot calculate the probability of this distribution. So what I will do is I'll refer to this Z distribution and here at alpha by 2 and alpha by 2, I'll calculate the Z value, because this alpha I can calculate, I can consider it as a probability. So here in this case, this alpha by 2, probability is nothing but your chance of occurrence. Okay, you can consider it as a percentage. So here alpha by 2 if is 0.25 if I am considering alpha as 5%. If my appetite is of 5%, then alpha is equal to 5, and then alpha by 2 would be equal to 2.5%, or in decimals we may put it as 0.25, because the probability will range between 0 and 1, right? So instead of percentage, we take the decimal values. So here where my alpha is equal to 0.05, my alpha by 2 will become 0.25. Okay. And 1 minus alpha will become 0.95, which is nothing but, what is this, guys? 1 minus alpha? It is my confidence level, no?
Confidence level, yeah.
Yeah. So 1 minus alpha would be my confidence level. Now let's see on this particular graph how it looks. Now we know that in any curve, the extreme values, the rare values will be always on the tail side. And the most frequently occurring and the most normal values will fall in the middle. Okay. So my confidence interval will be always in the middle. Okay. And it would be on the either side of the mean. Okay. Now the risk would be this extreme values. If I'm saying I can reach between 10 to 20 minutes, okay, if I reach at 5, in less than 10 minutes, 5 minutes, or if I reach by 25 minutes, so these are known as extreme values. And where these values will lie, it will lie on these tails, right, of my distribution. Now, these may happen because of the error. So where is my error? My error would be also on the tails. Now, what I'm saying is, now my appetite on either side of making the error is alpha by 2. So from here, I will take alpha by 2. From here, from the right hand side also, I'll take alpha by 2. So this regions would be my region of errors. So this is alpha by 2 and this is also alpha by 2. As I said, that area under the curve is equal to 1. That means the total probability of getting all the values, okay, inside this curve, inside this distribution will be the sum of all the probabilities of all the values would be equal to 1, right? So if I say that in my population, the values may range between minus infinity to plus infinity. If you take all the probability of all the values between minus infinity to plus infinity together, the sum of that probability should be equal to 1. So that is giving by this particular distribution. And if you see these distributions will not touch this x-axis. So that means it ranges from minus infinity to plus infinity. Now, here, if you understand that my error may be on the left hand side of the tail or on the right hand side of the tail. Okay, and I am okay with this much risk or this much error on either side, which I have considered as alpha by 2. My total risk was appetite was 5%, which I have divided on either side of the tail as 2.5% and 2.5%. So now this alpha by 2 is 0.025. Okay, and this side also it is 0.025. Now, what is this 0.025? It is 2.5% chance of getting the value. Okay, this is also 2.5% of chance of getting the values in this particular region. So how much portion of this particular curve is left out? In the middle, it is 1 minus alpha now, which is 0.95. Now what I have to do is, through this, I need to understand that, okay, in this particular curve, what is this limit and what is this limit? Okay, if I get this limit, I'll be 95% confident that the values would range between these two limits. If you remember, we spoke about empirical rule, right? There we said that if you take x bar plus minus 2 standard deviation, 95% of the values will fall within that range. So what does that mean? So it is like it states that there is a 95% confident that the values would fall in this particular range. Okay, so in the Z distribution, we consider that particular same empirical rule and we follow it here. Okay, so for 95% confidence level, my alpha has to be 5%, and that 5% I've divided it on either side. So on the left hand side it is 2.5%, and on the right hand side it is 2.5%. Now I want to find out these limits. So that is very easy. How I can find out that limit? I'll go and refer to the Z table. In Z table, I'll find out at this particular probability, okay, of 0.025, what is the value from the left. And here also, I'll find out from the right at probability of 0.025, what is the value. Now I'll get this particular Z value. Now it is very well symmetrical distribution. So if you take on the left hand side as 2.5% probability, you will get the values in negative. Okay, so it is Z equal to 1 minus 96. You need not to go and again calculate on the right hand side, as it is very much symmetric. Okay, on the right hand side it would be also the same value, 1.96, but positive. And your mean is exactly in the center, which is equal to 0. So if you're starting from the left and the right, okay, with an equal amount of probability, you will get the same value, but the same magnitude, but in the different direction. On the left hand side, it would be negative. On the right hand side, it would be positive. So that's the reason we consider this distribution, because this would help us in kind of quantifying the error on both the sides. See, if it is a different value, here if it is a different value, then I'm kind of I'm not dividing the error equally on both the sides, right? So if here it is, if I take 2.96, here if I take 1.96, the magnitude on the right hand side would be higher. So that's the in that case, I'm giving more, I'm becoming more biased towards the right hand side of the distribution. So to avoid all that biasness, and in statistics is very important, your decision should not be biased. Your calculation should not be biased. So that's the reason we go with this symmetrical distribution, and that too standard normal distribution, because here the magnitude on either side is exactly the same. Okay, when we are considering the similar, the same proportion from either side. Okay, so now let's see that how. So now this is how this distribution, the Z table look like. I will show you. So this is on the left hand side. Okay. So for example, from the left hand side, my interest is how much probability we are taking. We are taking 0.025, which is 2.5%. I'm saying I have the risk appetite of 2.5% on the left hand side and 2.5% on the right hand side. So here I will take the probability of 0.025. So in this particular graph, okay, I have to, one second, I have to take the, yes. So here in this table, I will go and look out for 0.025. So where is 0.025? Here it is 0.025, right? So this is the probability. So what is the value of 0.025? It is minus 1.9 and plus 0.06. So it is minus 1.96 for probability of 0.025. This is on the left hand side. Now, here in this distribution, in this particular table, all the probabilities are calculated from the left hand side. So if you want to calculate this particular limit, so then you have to consider the probability from left till this particular limit. So if this value is 0.025, okay, this particular region, then what would be this region, guys? If the right hand side of the region after this vertical line is 0.025, then what would be the
97 point.
yeah, so it is
25
1
something.
minus, as I mentioned, the entire area under the curve is equal to 1. So that is the total probability minus this particular region, 0.025. So what would be the answer? It would be 0.975, right? Now in
9.725, yeah, something like that.
9.975 only, right?
Yeah,
If you add 25 to this, it will be equal to 1. Okay, so it is 0.975. Now, in this particular table, to calculate the right hand side of the limit, I will go and find out the value as 0.975. Yep. Sorry, I'll consider this. Okay, so here if I go, here it is 0.9750. So what I'm getting, here also I'm getting 1.96. Okay, so you can go and you will get this Z table, just type Z table in Google search. Okay, you will get this entire table. So you will find that, okay, for equal probability from the left hand side and the right hand side, you will get the exactly the same magnitude, but with a different sign, okay, on the left hand side and the right hand side. So with that, okay, so here the probability starts from here. So at 0.025, I got the Z value as minus 1.96. And from here, if I continue till here at 0.975, I got this particular limit as Z equal to 1.96. So with that, I was successfully, I can able to find out these limits of the Z distribution. Now that Z value, so here my reliability factor, which is this Z alpha by 2, is equal to plus minus 1.96. Is this clear? If this is clear, then I think you got everything, man. So now you need not to worry. Rest everything would be very simple for you. Did you get this? Z alpha by 2 is equal to plus minus 1.96. How we calculated this? Okay, so now let's take an exercise. Okay. So here we have considered alpha equal to 0.05, 5% risk. Okay. Now let's take alpha equal to 0.08, 8%. Okay. Now you tell me a step-by-step technique, to calculate this Z alpha by. So firstly, if my appetite is at 8%, okay, then my error, I will divide it on both the sides. Okay. So here it would be 4%, here it would be 4%. And please stop me, guys, if any step is not clear. If my total appetite is 8%, what I did is I divided that entire risk on either side, because I don't want to be biased in terms of calculating the interval. because I'm not sure whether my actual population parameter will be less than my sample statistics or will be higher than sample statistics. Okay. So in that case, I've divided this risk equally on both the sides. Now what I will do is, now I will refer to my Z distribution, which is exactly symmetrical and which will kind of quantify this risk equally on both the sides of the mean. Okay. So for that, I will go and refer to the Z table. Now you tell me for finding out the Z value at alpha by 2, and finding out the proportion of 1 minus alpha by 2, how you will calculate.
Is it minus 1.7 to plus 1.7?
Hello?
I asked if it's minus 1.7.
Yeah, so sorry, I was talking on mute. So your alpha is 0.08, right? This is given in your problem statement. From that, you have to calculate the alpha by 2. So what is alpha by 2? It's just a half of your alpha. So if your alpha is 8%, then you have to consider it in decimals, it's 0.08. Then alpha by 2 would be 0.04. Okay, so with this alpha by 2, I can able to find out the Z value on the left hand side. To find out the value of Z on the right hand side, I have to calculate 1 minus alpha by 2. Okay, so here 1 minus alpha by 2 would be 1 minus 0.04. So what would be the value? 1 minus 0.04?
0.96.
0.96. Now you go to this particular table now. Okay. Can you see the table, the entire table? Can you tell me at alpha equal to point alpha with alpha by 2 is equal to 0.4, what is the Z value? So here is this value.
0.7.
Minus 1.7.
Yeah, 1.7.
Okay. So Z alpha by 2 is equal to minus 1.75, right? This minus 1.7 plus 0.05. So that is my value at Z alpha by 2. Now tell me what is the value at 1 minus alpha by 2?
1.7. 1.75.
Smart. Okay. So it is this. See, here it is coming as plus 1.75. Okay. So as you very rightly guessed, okay, so if you calculate Z alpha by 2 as minus 0.75, you need not to go and then calculate for 1 minus alpha. Just make it as positive, and that would be, and here you can verify it also. You are getting the same value, right? So now you got this Z. Now this is known as plus minus Z alpha by 2 is nothing but called as reliability factor. So see, at 8%, at alpha equal to 8%, what is my confidence level? Guys, what is my confidence level?
92.
92%. So 92%, what is my reliability? It is plus minus 1.75. At alpha equal to 0.05, what is my confidence level? 95%, right? At 95%, what is my reliability factor? Plus minus 1.96. So what is happening? If as I'm increasing my confidence level, my reliability factor is also increasing. If my reliability factor is increasing, the width of my confidence interval would also increase. Are you getting? So it's all about that particular formula, right? So here my confidence interval is directly proportional to this reliability factor. Okay. And as the reliability factor increases, my confidence interval also increases. Right. So, and if my reliability factor is increasing, that means my confidence level is also increasing. All right. So that is the relationship between all these values. Now we'll take one example and then we'll wrap up the class. Okay. So let's suppose I have a sample of, I'm a circuit manufacturing company. Let's suppose I have a sample of 11 circuits. I've taken a sample of 11 circuits from the large population, which I'm assuming it as a normal population. And in this sample, from all these different circuits, I've calculated the value of resistance. Okay, if somebody is from electrical engineering, okay, they can, or electronics, they can understand. So resistance is nothing but, it is one of the measures which restrict the current. Okay, so this is 2.20 ohms. Okay, this is my sample mean. Now we know from the past testing that the population standard deviation is 0.35. So here I can go with a previous approach because here sigma is known to me. So this is how the problem will be framed. Now they will say that, okay, now you tell me, comment something about the mean resistance. Okay, the resistance of my all the circuits which I'm producing. Okay, and that means I want to comment about the population parameter. So for that, I will also say that, okay, in the past, I know that this resistance is varying by 0.35 ohms. Okay, here and there. That is my standard deviation. So I have this much information. So what I will do, I will go and first take the sample. Let's suppose in my sample, I have taken only 11 circuits. And then I've measured the resistance for each of the circuit, and the X bar is coming out to be as 2.20 ohms. Okay, which is nothing but my sample mean. Now the question is determine a 95% confidence interval for the true mean resistance of the population. So that means I want to find out the confidence interval at 95% confidence level. Okay. So here they have already mentioned the confidence level, but usually they mention alpha. Okay, as we see in the subsequent examples. Okay, so here I know 1 minus alpha is equal to 0.95. So if in my distribution, if this central region is 0.95, then these two regions is nothing but 0.025 and 0.025, right? So this is my confidence level, and I want to find out this particular interval where my 95% of the values are placed. Okay. Now this particular distribution, I will go and infer with my Z distribution. And in this just Z distribution, I will find out these limits. And we have just now calculated at 0.025, Z equal to minus 1.96, and this side it is plus 1.96. Okay, so now what I will do is, now this is my formula for my confidence interval. This is reliability factor, Z, and this is my standard error. So this Z value I have to find out at alpha by 2. Okay, so mean I know it is 2.20. Z I can calculate, it is plus minus 1.96. This sigma is given as 0.35 in the formula, and the sample size also I know it is 11 circuits. So I know all the terms, all the components. I'll just feed that into this particular equation, and then I will get the interval. So now I will say that, okay, roughly around 2.20 plus minus 0.2068 is the range of is the mean resistance of the circuits in this particular population. Okay, so that would be my answer. And here I'm saying this population parameter would lie somewhere between this particular, in this particular range. Okay, from minus 1.99 to 2.40. Okay, so I'll stop here. Okay, I'll take a pause. Now, firstly, you tell me, did you understand the application of this particular confidence interval? Application in the sense, how this confidence interval is giving a business guy some insights about the data, through data, which help the business to make the decision. Did you get that point? Because that is very, very important.
Yeah.
Okay. So if you get that, now the second point is, technically, did you understand how this confidence interval is giving the inferences about the population? So why we generally going with sample, and then how this sample, through this sample, how we are calculating the point estimate, and why we are not going with point estimate, why there is a need of confidence interval. Technically, is it clear to you guys? Why are we not going with point estimate? Why we are going with confidence interval? Is that clear?
Yeah.
Yes. So simple reason is why we are not going with the point estimate, because we are dealing with sample, and definitely there could be some sampling error. To avoid that sampling error, I'm generally going with the confidence interval. Now the third important thing is this calculation part. So how this confidence interval we are calculating through this formula, and every component in this formula, like what the reliability factor, the standard error, all those things, is it completely clear, or do you have any questions or any confusion anywhere? So from now, whatever concepts you will learn, remember these three things. First thing, from a business side, and that I will put it as a very important, because the application is very important. Even if you get the formula, even you get, the technical part of it, but if you cannot explain it to the business, why is it, how the business can derive insights from this particular uh, approach, or this particular information, then it is of no use, right? So for that, you have to be first clear, right, how the business can utilize this information, right? So application is very important. So for every concept, you first relate why, what business will get out of it. where we have to apply these concepts. Okay, that application is very important. Otherwise, you learn the theory, you will have every knowledge about all these concepts, but when it comes to application in the real scenario, when somebody will give you the problem, you will not able to decide when to use what. Okay, so that's where I will stress a lot. Okay, so application is the foremost important thing which you need to understand. Second, the technical part. Third, the calculation part you can ignore as of now, because nobody will get into the formula, because now we have Python, we have all the different platforms. Nobody will consider how that is getting calculated. But on the high level, if you have an understanding that how that particular thing is getting calculated, that is fine. So no need of going too in depth and understand how that calculation is happening. Okay, so application part and the high level concept part, these two things are very, very important for you to understand. Okay, so with that said, we are done with this confidence interval. Now we will see different variation in this. Now we have just considered one particular scenario where we have some information about the population standard deviation. What if we do not have any information about the population standard deviation or population variance? So for example, in this case, we know that from the past testing, the population standard deviation is 0.35. What if this information is not known to us? Can't we go and then calculate the confidence interval? Yes, we can, but there we have to use another distribution, which we call as T distribution, which we'll discuss later. Okay, so when you are reading a problem, you need to understand first thing, what all information is provided to you, what is available, what is not available, then accordingly you have to decide the distribution. And these distribution, these are like statistical, we call as statistical tools. These are the tools which will help you to solve your problem. Okay, and you will see this distribution we will generally refer to even in hypothesis testing also. So if you are clear now, then it would be very easier for you to understand later concepts on hypothesis testing. Okay, so like that we have a variation. Then we know that there are multiple parameters. Okay, population parameters. We talked about mu, we talked about variance or standard deviation, and we talked about proportion. Now, for all these different parameters, we will have a different method, to come up with the confidence interval. So we have just seen for the mean. So I will show you this particular slide and then we will wrap up. Yeah. So confidence interval will be calculated for mean, for proportion, for variance. And in the mean, we will have two scenarios. One scenario when you have information about the variance or standard deviation about the population, and another scenario where it is unknown. So if it is known, we have seen that, okay, we will refer to Z distribution. If it is unknown, everything will be the same, but only the distribution would change. Here we'll go with the T distribution. Okay. So this we will finish, and after that we will go with the population proportion. Here we will see that how we can calculate the confidence interval for the population proportion, and the next the variance. Okay. So this is how we will cover this confidence intervals, and after this we will get into probability. Okay.
Yes, sir.
All right. So any questions? Anything? So what I will do is I'll give you a very logical break now, okay, and I'll give you certain examples along with the solutions to try to attempt on your own. Do it in this weekend, and on Monday we will proceed with this. And I purposefully want you to just sit on this and understand everything, in these things, because if you get this now, everything else is very much similar. The only the distribution would change. This part, like alpha by 2, the calculating calculation of this z values or the magnitude of a particular with a particular probability, that thing is very important. If you get that, rest everything is very clear. Okay, so tomorrow I will not take the class. I'll give you certain exercises. Okay, go through it. I'll give you only 4 to 5 questions, okay, along with the answers, but different way of solving a problem we will see. That's something you try to attempt yourself. Okay, you can refer to the Z table. And later after that, we will see that how we can do it in Python. Okay, Python, it is very simple. Just you pass one syntax function, it will give you the confidence interval. Okay. So fine. So we will connect on Monday then. Okay, and these attempt these questions on your own. All right. Is that okay?
Sir.
Yeah. And another thing is like I'm traveling tonight to US, so that is one more reason that I will not be available tomorrow because I will be in transit. And from Monday I will take the class. Okay, and I will be coming back on next Friday. I'll be traveling from US back to Hyderabad. So probably again on Friday, next Friday, I may not able to take the class. Okay, so I will inform you. Okay, but I will give you a proper exercises. And if you have any Python questions, then I will request Vikrant, to take the class and clarify the questions. Okay, whatever you have related to Python. Okay. All right, guys. Then thank you. Have a nice day. Take care.